Hello, welcome you all dear students. This is the simplest and easiest way of teaching learning process in our most popular, most famous YouTube channel. Physics Make It Simple that you made by Dr. Rajendra from Padma Shri Vikhe Patil Junior College, Pravaranagar, Loni. Today we are going to discuss a chapter Oscillations as long as 12th science is considered, and this is a lecture number 1. In this lecture we want to discuss with you what is oscillation, what is oscillation, what is the definition of simple harmonic motion, and how the differential of how the differential equation of linear S.H.M is to be calculated or is to be derived. So let us start the first article. What is oscillations? I will write on the board. What is oscillations? What is oscillations? What is oscillations? What is oscillations? So my first point is that oscillation is a periodic motion. Then again question arises, what is periodic motion? Periodic motion is a motion which repeats itself after equal or definite interval of time. So oscillation is a periodic motion. Oscillation is nothing but an oscillatory motion which repeats. See here, I will show one of the examples. Suppose this is a pendulum like this. This is a pendulum like this, and this pendulum is oscillating like this. See here, this pendulum is oscillating like this. This motion of the pendulum, moves along the same path to and fro, which repeats itself after a definite interval of time. We call it as oscillation. It is a periodic motion. It is a periodic motion because it repeats itself. I will repeat again. It repeats itself after a definite interval of time. Remember well, dear students, every periodic motion is not oscillatory motion, but every oscillatory motion is a periodic motion. What a fun! Motion of the planet around the sun, this is a rotational motion. It is not oscillatory motion, but that rotational motion, that circular motion, rotation of the earth around the sun, it is a rotational motion. It is also periodic motion, but though it is periodic motion, it is not oscillatory motion. So I will repeat the sentence again. Every oscillatory motion is a periodic motion, but every periodic motion is not an oscillatory motion. This is the most important sentence. So the definition of oscillatory motion I will write like this. So let me put this simple pendulum on the table. So we can write here oscillatory motion is a periodic motion which repeats itself after definite interval of time, along the same path, we call it as oscillatory motion. This oscillatory motion is a harmonic motion. Listen carefully. This oscillatory motion we call it as harmonic motion. Then again question arises, why this is called as harmonic motion? Because the equations of displacement, velocity, acceleration of oscillation consist of sine function and cosine function. That equation consists of sine function and cosine function. And remember well, dear students, that sine functions and cosine functions are harmonic functions. And so that the motion obeying such a harmonic functions, we call it as harmonic motion. So I will repeat on the board. This oscillatory motion, is called as harmonic motion. Harmonic motion because equations of displacement, velocity and acceleration of oscillation consist of sine and cosine functions. These functions are also called as harmonic functions. Harmonic functions. The motion obeying these harmonic functions, the motion obeying these harmonic functions are called as, the motions obeying these harmonic functions are called as harmonic motions. Harmonic motion, or best way we can say that simple harmonic motion. So take a screenshot at first, then we will proceed further. Take a screenshot. What is oscillation? Oscillatory motion is a periodic motion which repeats itself after a definite interval of time along the same path. This oscillatory motion is called as harmonic motion because equation of displacement, velocity and acceleration of oscillation consist of sine and cosine function. These functions are called as harmonic functions, and the motion obeying these harmonic functions, we call it as harmonic motions. So see here, equation of displacement, x is equal to a sine omega t plus phi, where this omega t plus phi we call it as phase of S.H.M. So what is phase of S.H.M? That we will see in the next lecture. X is equal to capital A sine omega t plus phi, where capital A is amplitude of oscillation. Then velocity we get is v is equal to, by taking derivative a, derivative of sine omega t plus phi, we get a omega cos of omega t plus phi. Then acceleration is get by taking a double derivative of displacement. A omega is constant and derivative of cos omega t is minus omega sine omega t. So omega and omega, we get omega square minus a omega square sine of omega t plus phi. So these equations, these are the equations of displacement, velocity and acceleration consist of sine as well as cosine function. These sine and cosine functions are harmonic functions, and the motion obeying these harmonic functions, we call it as harmonic motion, or best way we can say that simple harmonic motion. Then after learning the concept, introductory concept of oscillatory motion, we will have to discuss some examples of simple harmonic motion that I have already shown to you. The motion of a pendulum like this, the motion of a pendulum, see here, this is a motion of a pendulum, this is a motion of a pendulum, this is simple harmonic in nature. This pendulum repeats itself along the same path, the motion repeated along the same path, or pendulum moves to and fro along the same path at a definite interval of time. We call it as simple harmonic motion. Motion of the sewing machine, sewing needle in sewing machine, that needle is moving up and down continuously, that is harmonic motion. Motion of what? Motion of the oscillation of the prongs of the tuning fork. When tuning fork is hammered on the rubber pad, then prongs vibrate to its main position, that is a simple harmonic motion. Motion of a pendulum of a clock is an example of simple harmonic motion. So these are some examples of simple harmonic motion, or we can also say the motion of the oscillation of vibration of different parts of the vehicle when the engine is on. When the engine is on, then parts of the vehicle is vibrating like this. That vibration is along the mean position. This is also a type of simple harmonic motion. Motion of a swing, the motion of a swing is also a simple harmonic motion. So simple harmonic motion is a oscillatory periodic motion. So we will prepare now a definition of S.H.M. This is some introductory part of oscillation. Take a screenshot and then we will proceed further. Take a screenshot. Okay, then we will discuss the definition of simple harmonic motion. The definition of simple harmonic motion. So let me clean the board at first. Let me clean the board at first. Let me clean the board at first. While learning the definition of simple harmonic motion, you concentrate the equation f is directly proportional to x. See here, definition of S.H.M. Definition of S.H.M. So we have to concentrate the equation f is directly proportional to x. What is f? F is restoring force. What is x? X is displacement. See here. See here. See here. This is the oscillation. This is the oscillation. This is the mean position of the particle. This is the mean position. This is one extreme position. This is another extreme position. If one extreme position is positive, then another extreme position is negative. This is the mean position. And maximum displacement of the particle from its mean position, we call it as amplitude. So amplitude, this is amplitude from the mean position. Come to again mean position. This is also amplitude of mean position. And what is force? Force is restoring force. That means that force is moving, that force is directed like this. See here. Force is directed like this. Force is directed towards the mean position on both the sides. From here. When the bob is here, then it is directed towards the mean position. When the bob is here, the force is directed towards the mean position. Listen carefully, dear students. That restoring force try to restore the body to its mean position. When the body moves here, restoring force try to restore the body to the mean position. When the body is moving here, the restoring force try to move towards the mean position. That means restoring force is always directed towards the mean position. That's all. Most important point. And another thing is that displacement of the body is always measured from the mean position. Always measure from the mean position. You should remember these two sentences before preparing a definition of simple harmonic motion. What are the two sentences? Restoring force is directed towards the mean position. Restoring force directed towards the mean position, which try to restore the body to its mean position. And displacement of the body always measured from the mean position. That means from this mean position, displacement is measured away from the mean position. Displacement is measured away from the mean position. It clearly indicates that, dear student, restoring force and displacement are oppositely directed. These are the most important points before preparing a definition of simple harmonic motion. Restoring force is directed towards mean position, while displacement of the particle is measured from the mean position, and both are directly proportional. That I have written on the board. This is restoring force, this is displacement of the particle from the mean position, and by making use of all these concepts, we have to prepare now a definition of simple harmonic motion. So here, simple harmonic motion, let me put this simple pendulum on the table. Okay. Definition of simple harmonic motion. Simple harmonic motion is an oscillatory periodic motion. That we learn. Simple harmonic motion is an oscillatory periodic motion in which restoring force or acceleration, because restoring force produces acceleration. So restoring force into bracket acceleration is directly proportional to the displacement, okay, and magnitude of restoring force and direction of the restoring force is opposite to the direction of displacement. I will repeat again. Simple harmonic motion is an oscillatory periodic motion in which restoring force is directly proportional to restoring force is directed towards the mean position. This is most important sentence at first. Restoring force or acceleration is directed towards the mean position whose magnitude is directly proportional to the displacement which is measured from the mean position. I will repeat the definition I will write the definition on the board, dear student, at first. So here I will write what? Simple harmonic motion is an oscillatory periodic motion in which restoring force into bracket or acceleration is directed towards the mean position whose magnitude is directly proportional to the displacement denoted by x, displacement measured from mean position. And from this we can write F is equal to minus kx. Negative sign indicates that restoring force and displacement are oppositely directed. Negative sign indicates that restoring force is directed towards the mean position, while displacement is measured from the mean position towards the extreme position. Both are oppositely directed. That is the meaning of negative sign that you should write. Meaning of negative sign. Well, this K is called as force constant. K is called as force constant. I will write here. Negative sign indicates that force and displacement are oppositely directed. Force and displacement are oppositely directed, where K is called force constant. This is the definition of simple harmonic motion. Take a screenshot. This is a definition of simple harmonic motion. You should concentrate the equation F is directly proportional to x, and the meaning of negative sign is most important in the definition of simple harmonic motion. So up till now we learned what is oscillatory motion. We have also discussed some examples of oscillatory motion. Why oscillatory motion we call it as harmonic motion, that also I have explained, and we have prepared a definition of simple harmonic motion. And now we have to discuss the next article, differential equation of linear S.H.M. So let me clean the board at first. Differential equation of linear S.H.M. Differential equation of linear S.H.M. Differential, I will write here, differential equation of linear S.H.M. Very simple. Number one, by the definition of linear S.H.M, we have what? F is equal to minus kx. This is equation 1. By the definition of linear S.H.M, we get equation F is equal to minus kx. According to Newton's second law of motion, we can write F is equal to ma. Number 2, according to Newton's second law of motion, according to Newton's second law of motion, F is equal to ma, which is equal to m d2x by dt square. Acceleration, a double derivative of displacement, we get acceleration. This is equation 2. Then number 3, comparing equation 1 and 2, we get what? We get what? Comparing equation 1 and 2, we get m d2x by dt square is equal to minus kx. So here m d2x by dt square plus kx is equal to 0. Then divide throughout by m, we'll get what? We'll get like this, d2x upon dt square plus k by m into x is equal to 0. Put k by m is equal to omega square. Put k by m is equal to omega square, where omega is angular velocity. Omega is also called as angular frequency. Remember well, dear student. It is angular velocity or angular frequency, one and the same. By putting the value of k by m here, you will get what? d2x by dt square plus omega square x is equal to 0. And this is the d2x by dt square plus omega square x is equal to 0. This is the differential equation of linear S.H.M. This is a differential equation of linear S.H.M. Okay, we will stop here and we will proceed further. Before that, if you like my lecture, then comment, give your reply in the comment box. If you have any suggestion in your mind, you also suggest in the comment box so that I can improve my teaching learning process for you. And subscribe my channel. This is my humble request to you all. Be alert to my channel. Listen all the lectures very carefully to make it physics very simple for you. Thank you very much.